All right, honors geometry students, here we are with exercise 6 from Friday's notes, the Friday before spring break, which was March 20th. So we're looking at exercise 6, and the goal of the question is to determine the measure of arc QR, and then the twist is we're solving for the measure of arc QR in radians. All right, so if we remember what a radian is, the geometric definition of a radian is the arc length divided by the radius. How many radii fit in a particular arc length? So it's a measure based on a radius. Okay, so if we want to solve this problem, we need to find the length of arc QR. So our goal is to take the length of arc QR and divide it by the radius. So we have two things to kind of determine here, right? So let's get to work. They told us that the measure, we're given circle T, so QT is a radius, TS is a radius, and they told us that the measure of angle RMS, so we follow that along, angle RMS is inscribed as it's formed by a chord and a chord, and M is on the circle, and that angle is 50 degrees. So if we recall, the inscribed angle is half of its intercepted arc. So that would indicate that the measure of arc RS must be 100 degrees. Okay. Well, they told us circle T, and we could assume a straight line. That means QS is a straight line that goes through T. So QS is a diameter. Diameter cuts a circle in half. So if this if this arc measures 100 degrees, then the measure of arc QR must be 180 minus 100, or 80 degrees, right? So the reason that we're getting all of this information is we need to get the length of QR, and to get the length of to get an arc length, we need the fraction of the circle multiplied by the circumference. So right now we need to get, what fraction of the circle we have. So if we want to solve for arc length, we have 80 out of 360 multiplied by the circumference. So now our focus is to get the circumference. Well, the circumference relies on the radius. So now I need to figure out the radius. So where am I at now? I recognize that I have an 80-degree arc, and across from that 80-degree arc I have angle RSQ. So RSQ is inscribed, and its intercepted arc is 80 degrees. So that means that the measure of angle RSQ is 40 degrees. So the measure of angle RSQ is equal to 80 degrees divided by 2. So the measure of angle RSQ is equal to 40. So then our goal is still to get this circumference here. So if I want to get the circumference, another piece of information that's useful is this arc over here is 180 degrees, and it's formed by a diameter. I feel like we've done this in a previous problem, but maybe you didn't see the video for that. So if this is a diameter and this arc is 180 degrees, then that means that angle QRS is 90 degrees. So when they gave us that QR is 4, that should help us get the diameter. And when we know the diameter, then we also know the circumference and we know the radius. So I'm going to solve for QS based on the right triangle QRS with a leg of 4 and an angle of 40 degrees. So I can do the sine of 40 degrees because I have the opposite side and I want the hypotenuse. So the sine of 40 is equal to the opposite side of 4 over the hypotenuse, which is QS, which just happens to be the diameter of the circle. So when I solve for QS is going to equal to 4 divided by the sine of 40, and 4 divided by the sine of 40, we'll put that into the calculator. 4 divided by the sine of 40, we get that QS is approximately equal to 6.22. I'm going to store that number in my calculator. There's many more digits that we cut off there, so I'm going to keep that in my calculator. So Now my goal is to solve for the length of QR. So with the arc length, we kind of have that set up right here. So I'm going to show that work over here. QR is going to equal, the length of arc QR is equal to 80 out of 360 multiplied by the circumference, which is the diameter of QS, which we call it 6.22, but we don't want to cut off all those extra digits, times pi. So when I put that into my calculator, I type in 80, I'll put it in parentheses, 80 divided by 360, multiply that by 6.22 times pi, so the diameter times pi, and that gives us about 4.34. So QR is approximately 4.34. I'll store that in my calculator again. Okay. Now we said that if I want to solve this problem, I'm going to take QR, the length of QR, and I'm going to divide it by the radius. Well, since QS was the diameter, the radius is half of that. So to get the measure of QR in radians, we're going to take the length of 4.34, and we're going to keep all those extra digits after that, divided by 1/2 of the diameter. Well, the diameter was 6.22-ish, so 1/2 of 6.22-ish. And then we're going to round that to the nearest tenth because that's what the directions say. So the measure of QR in radians, when I put this into my calculator, is going to be approximately, well, let's type it in. So we'll take 4.3, we'll take that entire number, so I don't round too early, and divide that by 1/2, or just 0.5, times, steal that other number from before. The diameter was 6.22, but I'll keep all of the digits there because I want to be precise as possible at the end. And I get that the measure of QR is about 1.4 radians when I round to the nearest tenth. Okay. I would call that the long way. That is the long way to solve this question. It uses the definition, the geometric definition of a radian, and sometimes doing it this way with the geometric definition is way faster. But sometimes using the conversion is way faster. So I'm going to show it the other way, and it should be way faster just based on the given information. So it's probably up to you as a good student to know that there are kind of two ways to think of a radian, right? There's the geometric definition, and for this particular problem, it took longer, but in other problems, that might be the fast way to go. But there's also a conversion based on the unit circle. So I'm going to solve it with that conversion idea. A full circle is 360 degrees. The full circle measures 360 degrees. A full circle is also 2 pi radians. So I can do degrees out of 360 is equal to radians out of 2 pi. Well, this problem was really set up nicely for this type of conversion because one thing that we solved for right away was that QR was 80 degrees. So I could do 80 out of 360 is equal to the radians, the measure of QR in radians out of 2 pi. And when I solve that problem, I'm really just saying that the measure of QR in radians would be equal to 80 multiplied by, or 80 divided by 360 multiplied by 2 pi. That's how I would solve for the measure in radians. So when I solve that proportion, I would just put that into my calculator, 80 divided by 360, and then I'd multiply that by 2 pi, and I end up getting the same exact answer. Look at that. I get the same exact answer, and I get the measure of arc QR is approximately 1.4 radians. So sometimes problems are set up much quicker to be the quick conversion. Other times problems are going to be way faster to solve by using the geometric definition of a radian. So you kind of just be a responsible geometry student and know that both of these can be useful, and sometimes a problem is easier to do this, and other times the problem would be easier to do this. Thanks for checking in.